Recording looks active. Okay. All right. Welcome to week 3. This is IT417. Data extraction, transformation, and loading. This week we're going to talk about manipulating data to match the target, basically changing it so that your ultimate destination for your data is consistent, transferring data into the usable formats, converting and reformatting the data, cleansing the data, and verifying data consistency. Because in the end, you want your data to be reflective of your end goal and where it is that you want it to go. So with that, I better do a sound check. Sorry. Yeah, I think that's right. Okay. All right. All right. At this point, chapters 1, 11, 19 from the reading, which is what the discussion board 1 was about, is complete and over with. Individual project is also at this point late for part 1. Discussion board part 2 is late. Discussion individual project number 2 is late. And then since number 1 feeds into number 2, you kind of had to do both in order to get to this point. This week I'll go over the requirements for unit number 3 and discussion board number 3 as well, which we'll do this week. So week number 3's discussion board is about what to do with distributed database management systems and what are they used for, how are they used, what's their advantages, what's their disadvantages, why are they good, why are they bad, what situations matter, what situations don't matter. As an example, like sensor data from lots of sources, those are pieces of data that you can use to feed into a data lake, and you need to transform that data real time into something that can be used within a data lake or a data warehouse or a data system database. But in that context, the transformation of it is done real time from its source to the destination to feed into the place. Distributed database management, however, on the other end is you have lots of databases that have to be synchronized, possibly even geographically dispersed, that have to be synchronized for transactions. And in that context, you need to have them be able to talk to each other, send transactions to each other, make sure that they stay consistent time-wise. The timing of transactions matters a great deal. It's really good for retail, commercial resource in retail on the internet, whereas feeding lots of sensors is good for centralized database, but it's not good for distributed database. So they all have their both pluses and minuses. So please give a couple examples of, talk about it in the thing, and I will ask questions, and your responses to those questions will help determine your grade for that particular assignment. This is the data transformation process website link for them to use. Additional information, if you need to get on data mining, there's a really good peer-reviewed journal article on data mining and the usage of automation within the ETL process. This is worth reading. It's one of the things I had to dig into and explain as part of my doctoral, working on one of my doctoral classes regarding data mining. So this was actually pretty good. Remember, the individual project week 3 is about the data transformation procedure, how you want it to work, how you expect it to work, what is your punch list of things that have to occur in the order that they occur in order to make the data transformation system function for within your project. In order to achieve week 3's assignments, you would have to be adding new sections of about 4 to 6 pages, have specific business rules and functions that are specific to transformation, extracting data, and the rationale for why that matters to the business. That should probably be a page of its own. You need to describe the specific steps, including screenshots and the rationale used during the transformation process. So basically showing evidence of your SQL statements actually working and achieving what your goals are. And as you perform each of those steps, make sure you list the size specific data validation rules that you're going to use to be within this. This is how you get graded. clean the data by filtering the data sources. How is it going in from rejected or valid streams and transforming data to become validated and therefore entered into your database or data lake in the process? Transforming that data into a usable format such as JSON or XML or flat files if you're going to use that. Document the data validation results, document any data validation errors, fix corrections, running a profiler, basically proving that your data sources can be cleansed, and that you can get results into a satisfactory state, right? So make sure you do cite all your resources. Expectations is basically you need to create a bunch of dummy data using the various types of sources of that data or various formats of that data and converting it into something that then consistently converges into something realistic, right? So things that I have to look for is like, well, do you business rules focus on connecting to the data? What does it do to make the data connect? What does it do to make it converge to transform into something consistent? How are you looping through your SQL statements? How are you reading in your data file? Do you need to focus on the script to be reusable, repurposed? Is it easily modifiable? What's important about it? How was it done? Did you write it in a very reusable method? Was it easily flowcharted or pseudocoded? So those kinds of things is what I'm supposed to be looking for. So in any data parsing process, be mindful of what you have to accomplish in the end, right? Your goals and your outcomes need to be well understood, so you can meet your final statement of your project, your milestone, where your objective is, and ultimately how to get there. So your IP3 should have a business plan with the common sense of purpose and that allows everything to be worked off of, right? So this is actually the thing that's given to me for how to grade your IP. This is my expectations. So I have to go through there, and this is the expectations of: do you have a plan? Do you have an end goal in mind? What's your scope of the document? How do you get there? How do you determine what you're doing? What's the correct parsing or scripting language used for parsing and provide the data from there? What do you read it from? What's the kind of screenshots of your SQL statements? So ultimately, you have to convince me as if I was QA or as your business manager that you're achieving the goal that the objective is in front of you. So in that case, you have to make a case for how this actually works, what are you doing, and able to get there, right? And don't forget to back up your data sources so you don't damage them. All right, at this point, I'm going to share the video for the week.
The idea of being able to create a robust, dynamic, and quick transformation of data into information is an important need for any business. So the whole concept of data extraction, transformation, and loading, ETL, is an important one. The era of waiting days, or even weeks in some cases, for data to be turned into a meaningful format are gone. Having useful data in a timely manner can mean the difference between a successful business and one that is closing its doors in today's competitive world. Having rules that allow for a quick review and transformation of data into information is critical to any arm of a business, from marketing to the actual shop floor. A good set of rules allows for real-time data, or as close to real-time as can be expected. The rules need to be as detailed as possible, and an easy-to-understand set of steps and scripts to run should be created to process the data. Of the ETL subprocesses, the transformation can be the most difficult and critical. It is in transformation that holes in logic, if not found before implementation, can create big problems for attaining a true transformation into information that can benefit the company. The ETL process can touch all areas of the company, from marketing to sales and information technology, IT, to production. So coming up with a process that intelligently turns the data into useful information is of great importance. If this process is completed in a thorough manner, decision makers have a great deal of information that they can use later to gain more market share or to be successful in general. The transformation portion of the process takes the data handoff from the extraction process and works on massaging the data into something that is useful and can be worked with based upon the company rules that are in place. These rules will define the success or failure of the whole ETL process. Though the extraction and the load processes are more simple and more rigidly assigned as tasks business-wide, the transformation process takes on a life of its own from company to company. One format error or one omission of data can make a huge difference in the meaningfulness of the information that is produced. Having detailed rules is of great importance to the process, and they should clearly assign logic, the stage in the process, and the owner and group or person responsible for maintenance of said rule. This process, although the appropriate stakeholders are necessary, should be maintained and put together by the IT and programming department. That is, the transformation process should be owned by IT. The goal of getting a more industry-standard ETL process should have some major stakeholders and buy-in from all groups within the company, but the responsibility for designing, developing, quality assurance, and maintenance should all run through IT. Although the ownership of a project such as this can be stretched, it is important that it resides in the area where it should be, and needs to be, which is IT. Department and project managers need to be aware of this and should push to keep it there.
Okay, so the transformation phase is basically taking data that's in a common format to simplify it, standardize it. So XML, JSON has done a good job of standardizing formats of data. So taking that, converting it in from those file formats where your sources are, or converting them into that set of standardized process formats, and then reading it in from your through your transformation process into the final destination for that data. So using whatever it is to convert it into a JSON format, for instance, right? Or an XML format where it's all tagged and organized with as many of the cells potentially filled in as you can, allows you to convert the data to something that can be easily understood and then merged with other sources of data using that same means. So it ultimately, that is there to ensure that you have consistency of sources, and all your multiple sources can then be deferred. And it's easier also when you have a standardized process for say XML or JSON, that you can then take lots of smaller databases or disparate type databases and then build the set of tools needed to convert from those sources into the standardized format that you then use, that you can reuse for multiple projects to convert over, right? So very complex systems of data, distributed databases, management systems, it can take weeks or more to complete the transformation itself. And that is actual processing time, kind of depending on how complex and how big the data is. If you're dealing with millions of records, or if you're dealing with a database the size of like the IRS, it could take you weeks to months to convert data from one year to another if they ever had to change their database formats. So that's another reason why to make it standardized, so that you can ensure no loss of data or corruption of data in the process of it, and to help speed up the execution performance by optimizing the virtualization layer or the underlying infrastructure needed to execute that stuff. Vendors over the years have been adding methods to insert or export or import data from these standard formats for a while, because they know standardization helps with rapid transformation, easier to migrate to their products, easier to sell their products, because if it's a difficult to migrate into a product, that is turned out to be a very hard selling point for companies to convert to different styles of databases or between them, right? So making it easy to convert has helped them introduce their products to market and bring their innovations that then businesses are easier to take advantage of. So they do that through compartmentalization, through containerization of the virtualization layers in order to be able to migrate between systems. They've done it with standardizing of formats and exporting of formats. and even building tools to help you convert other people's databases into the format that is easily inserted into your own. So vendors in a lot of ways have helped the engineering side of the world, or IT, by giving us the tools needed to help migrate stuff to their systems or from their systems through standardized tools. The process of transforming is you want to create basically a robust set of language necessary from your true sources to your destination sources. So in this case, in the picture here, I have a bunch of data sources, lots of disparate things, could be geographically disparate. I built a set of scripts that you then convert the data into those standard things. So you now have a set of standard JSON or XML files with your ETL system. Then you send them all to the database warehouse, which then puts it into the various pieces. So you can have the OLAP for processing it. You can have your reporting tools then be able to use all the different databases or data sources into as if it's one system, and then give you a consistent set of information for decision makers. You can then mine the data for additional information. You can find out new details about it. Basically, the process you encourage how your business will actually process. So, omitting data can make big differences in the meaningfulness. So, this is an example, right? One of my favorite stories is that an Oxford comma. Oxford comma is usually used in the list of things like this, comma, this, comma, this, and this. Or this, comma, this, comma, this, comma, and other. The Oxford comma typically is used in the series of chains of stuff, right? So a while ago, Maine, the state of Maine, was sued by a dairy commission that was performing delivery of milk and butter and things like that for a contract under the state of Maine, so that people can get the products, the goods out, right? Well, those people were working long periods of hours for a while there, and in their contractual language, it was they had to do this, this, and this. But because they forgot the last comma, it was argued that the delivery, I forgot the exact details, but they were doing two things, and because of that, they were able to um, do those multiple things. But because the last two were linked together without the comma, they had to be done together in order to satisfy a criteria in a court case. So that lack of comma then allowed them to sue the state of Maine for overtime, which resulted in like tens of millions of dollars being paid back overtime from the state of Maine to the people doing the work of the delivery because of the lack of comma in their contract from a string of things that they were supposed to do that they would not be authorized overtime to do. So, but because that comma was there, they didn't. The last two had to be linked together at all times, and therefore they were able to get sued. They were able to sue successfully for overtime. So, like I said, context matters. Details in the process matter. Omissions of specific things in lists of data matters. Oxford comma. That matters. So ultimately, your extraction and load processes need to go step by step and a staged method so that you can put those systems from point A to point B, point C, point D in a very planned and numerical way. So as an example here, this uses the order of operations because everything done inside the parentheticals must always done first and foremost before any other mathematical thing, and then followed by things like multiply and divide, which is here. So in this order of operations, 4 plus 1 is 5. So then 3 times 5 makes 15. And then you go plus 1 makes 16, plus 1 makes 17. Then, yeah. I guess the math is wrong. I didn't bother to look at that very closely. 15, 16, 17, that makes 8. Yeah. Oh, that looks silly. Okay. All right. It is crucial to understand that all the basic processes in the extraction and transformation process are important, and that the phase has historically been one of the hardest to understand and to standardize thus far in the IT industry. Because obtaining the data is easy, transforming it to where you need it to go in the end correctly with all the other data sources can be difficult. It takes a lot of planning, takes some good execution, takes a lot of understanding what the data sources are and what your end goal is ultimately needs to be so that they can all be useful in the end. And if you get it incomplete in the end, you may end up with a case where you have consistent data, but it doesn't meet your objectives of your business. And that is also not necessarily helpful because you need to have enough of the data captured and understood so that it can meet your objectives of the business. So reviewing the process all the way from start to finish is also important in the deal. So you got to proper plan it, make sure the logic works out, and along the way, verify that your information is good. So the process of loading it to the memory, reading through the data, putting it into the proper format, and then preparing it for upload into a warehouse. So you have to go through this process for every source of data, and in the process, review it, ensure it's consistent and it's achieving what your objective is. Failure to test at every stage could end up breaking your whole thing because if you don't correctly ensure that the data is in the proper format, downstream at this point, then downstream you could end up having a lot of bad data inserted where you don't want it, and that could be a nightmare to solve at a later date. So, but good data supports business analysis, business goals, supports decision making, and helps you identify trends and problems. Data transformation requires rules, requires understanding how to convert from the old data to the new data, provides a roadmap for easy assembly and QA auditing of data transformation process. Idempotent and immutable. So idempotent basically means that it is unique and understandable and repeatable. Immutable refers to the fact that it is basically indisputable and unmodifiable, or proven to be a truth source that cannot be modified accidentally. So, if I remember correctly, overly complex, difficult to understand can help make it harder for people to manage your database. So you want to make sure you have correct languages. You want to perform it in the direct manner. You want to make sure you use object-oriented programming, lots of functions, lots of reusable code pieces of data in order to ensure that you have the best developed and integrated processing tools. So scripting languages and programming languages are useful for these are things like PHP, Perl, Ruby, .NET. Sometimes JavaScript can be used for this. I've seen Python used for a lot of these things but these particular ones here, PHP, Perl, Ruby, .NET, they're all object-oriented based programming languages and help with the reusability very easily. Raw data is merely collections of numbers and information. Good data has meaning, good data has context, gives you information, provides things that can be useful, gives you the ability to make good decisions, whereas bad data is just garbage in, garbage out. It tend to not be helpful, though at times knowing your bad data is just as important as knowing what your good data looks like. So you know what you're looking for and what to where to find your errors so you can trim out those problems. It is common to visualize all data with graphs, reports, charts, outputs that you can be used in very fast manner to visualize data understanding so that people who make decisions have something they can work with. Analysis is the process of turning good data into something that decision makers can understand. It helps you identify trends, potential problems, where your negatives are, where your positives are, allows you to do preemptive action, and gives you a historical archive of past information. Historical data tends to give you trend analysis and information, provides context to the data collected, and gives you the ability to understand how data is interrelated and how they interact with each other. Metadata is there, gives you characteristics about the data so that you can do analysis on where the data came from and what it was about. Data mining is a process to extract non-trivial or unknown data relationships based on information that is available to you, right? Helps you find how to make data useful. The process of going from business understanding to data understanding, partitioning, modeling, and then evaluation. So you constantly flowing around your data to understand what it means and how you do it, how to accomplish it. The tools to process that migration. You basically take all the sources of data, turn them into a data warehouse, transform it, and process it into something useful. Then you can mine it to make better reports, better understanding of the data, and then you can interpret it into useful knowledge for the business. That allows you to help understand where it's going from and where it's coming from. DTL process lets you profile the data so you have an understanding of what it is, what it means, so you can properly migrate it to help improve the understanding long term and to help clean out any bad data in the process, right? So ETL process, a couple of diagrams here on how the ETL process goes from left to right or circular, right? That is all of my prepared slides for today. I hope you've not, I hope you are still actively taking care of the class, still doing work, still reading into it. And it's been a while since I've heard from you. I've tried to reach out a couple times. I hope to hear from you soon. And with that, thanks. And hopefully you find this recording helpful in your studies and journey. Thanks.